Welcome to the Time CNC Podcast, your go-to show for precision, efficiency, and innovation in CNC manufacturing. We're here to help you cut time in all of your CNC endeavors. Whether you're a CNC enthusiast, CAD/CAM aficionado, or into robotics, this podcast is for you. Join us as we explore cutting-edge perspectives on machining metal parts. Discover the perfect tools and streamline your production processes. Precision meets progress on the Time CNC Industry Podcast. And now, here's your hosts, Al Martins and Stephanie Bate.
Hey, Steph.
How's it going?
I think every episode I tell you the same thing. I love that intro.
It's a really good one. Not biased at all.
No, I'm not biased at all. Certainly, if anybody likes that as much as I do, mention it in the comments. I'd love to hear about it.
Absolutely.
So, Steph, tell me about today's guest. What's our title? What are we doing?
Well, we're having a tool talk, so we're choosing the right instruments for CNC success with Tony. Awesome guest. So really excited for tonight's episode.
Yeah, me too. Yeah, we're looking forward to hearing what Tony has to say on the other side of the earth. Yeah, I'll let you, Steph, man the questions and talk to the people on the other side. I see Luis Rivo's on the other side of the earth, who's joined us too. So I'll let you reply to him.
I will. Okay, I'll step out
right.
and I'll bring Tony in.
Take care.
Bye.
Bye. Hey, Tony.
Hey, Al, how are you?
I'm doing great. How are you?
Doing well, thank you.
Excellent, excellent. Well, Tony, it's really nice to have you. It's been a little while since we've had an opportunity to really chat about, what your adventures have taken you on, and we're excited to have you all the way from California. It's really a nice opportunity to get together with this podcast, and we're excited to have you with, choosing the right instruments for CNC success, and you've been very successful down that road. So you're the perfect guest to have.
Oh, well, thanks.
Yeah, thank you. So, Tony, the first thing we normally do is talk about your journey. How did you get to be where you are today? What was it like when you decided, hey, I need to get some CNC machines in my life? Tell us about that.
Well, the path began growing up in an automotive machine shop. So we were engine builders, and I was around grinding and honing and things of that nature from really, really young. And we had a little bit of manual equipment, and we ended up we began racing karts, go-karts, as people like to call them. And in the process, we ended up doing machine work for a guy who had moved to our county. We're pretty remote, and he needed a source for machining. So we were actually doing the machine work initially, and then he asked if I would be interested in actually building the engines for him, and then he would just distribute them. So that was a business I started. I honestly don't remember if I was in 8th grade or maybe early high school. And I did that for quite a while. And the karting scene, at least locally, kind of evolved to allow more and more modifications. Karting is not that way now, but as these modifications came around, the gentleman that I was working with ended up leaving the area, and so I ended up with kind of a default business as he created a vacuum to supply these race engines. So we were racing, we were really successful, and I was building engines for other people, also very successful. So as these modifications were being allowed in the rules, I started coming up with ideas for things to improve the race engines. And it really got beyond the ability to generate the shapes and features that I wanted with manual equipment. So I had to start figuring out, well, how is this stuff done? And so I did some research and found out that CNC equipment was the way to create this stuff. So I graduated from high school and actually, of all things, ended up going to paramedic school. And so I was a paramedic working. It allowed me to work about 3 days a week and then have 4 days off per se. And I decided I would purchase one of these machines primarily as a write-off, but also to have the ability to kind of grow this engine business, because that's really what the focus was at the time.
Sure.
So I ended up finding a machine at a dealer that was had been sold to someone. Unfortunately, the gentleman had passed away. It had almost no time on it, and I was able to purchase it. So I put this machine in the back of my family's automotive engine building facility.
Sure.
And basically never got a chance to build my race engines. What is we're pretty rural, and as people would come in to have their cars worked on or engines rebuilt, they would see this newfangled whiz bang thing that they thought was magic and start talking about it. And
where was this, Tony? Where were you? Were you in California then?
Yeah, so I live in the mountains of California. It's on the eastern side of the western slope of the Sierras. I'm literally about 10 to 12 air miles north of Yosemite Park.
Okay.
So we're about 120 miles due east of San Francisco. So we're kind of central California.
Yeah.
We're not on the eastern side, but on the west slope of the eastern mountain range. So it's rather remote.
Yeah.
But it was close enough that some of the people who had seen this device and were speaking about it had relatives, of all things, in the Silicon Valley and the surrounding areas. So I literally got a fax one day, which was about 20 pages of print. And the last page had a handwritten note that said, call this number. And so I called this guy, and fully assuming that this was a misdial number.
Right.
And said, hey, I think you sent something to me by accident. He said, well, my cousin was up there and saw that you had one of these machines. And do you have? I said, yeah, I have one. He said, well, can you make these parts? And I've always said I was too stupid to be scared. So I told the guy, yeah, I can make them.
Yeah.
So I had a 20-inch travel or 22-inch travel machine. These parts were like 38 inches long.
Seems reasonable.
Pardon me?
Seems reasonable.
Yeah. So one of the first jobs was I had to remove the doors on the machines and get some more, not effective travel, but effective area for the parts. And I built a transfer fixture on the table that allowed me to do these in segments and then relocate them accurately. So I didn't know I was doing it the hard way. I just knew that's how I had to do it.
Right.
So I made the package of parts, and the guy sent me another package. I did some more of them. Pretty soon he showed up and looked at the machine and said, how in the hell are you making these parts on that machine? So I showed him, and he said, oh, you need to get bigger equipment. So that was one of the first real kicks into diving hard into the manufacturing. At that point, I was still dabbling, and I was 100% self-taught. In fact, I didn't own a computer until this machine showed up and had a PC in the control. And it had a resident cam system, which ended up being Gibbs cam. And I broke a lot of tools off figuring out how to run that. In fact, the guy that installed it was giving me all this what for on these fancy features. I said, hey, time out. I need you to show me how to turn this thing on. So I was lucky enough that when the dealer at the time offered, I can't remember, I think it was maybe 5 days of training. So I said, well, I think I want 1 day, and then will you agree to come back later when I can ask intelligent questions? Because I'm just going to drown the first day. And they said, yeah, we'll do that.
Well, you said that was a used machine, didn't you?
Well, it was a used machine. It was actually a Fidel.
Yeah.
It was sold by Magna Machinery.
Okay.
In the Bay Area.
Yeah.
They had sold it to a gentleman I want to say like 18 months prior or something.
Sure.
And he had the machine for a very short time, and unfortunately he got sick and ended up passing away. And his wife ended up with this machine. I never met the man, but the long and short of it is Magna, my understanding was that Magna purchased the machine back from her.
Okay.
And then with the intent to resell it, and
Of course,
they
yeah.
did so. They resold it to me. So
And
that was
that had the 88 control on it, didn't it?
No, it had the 32 MP. So the 88,
32 MP.
the 88 control was the standard Fidel control.
Right.
The 32 MP was the 32-bit computer.
Wow.
Yeah, it was a rocket.
Oh yeah.
I decided I was going to put some more RAM in it at one point, and I think I had to pay about $1,800 for 4 megabytes of RAM.
Yeah.
Yeah.
I remember those days.
Hey, that was it. That was cutting edge technology, and we were able to use it, So being 100% self-taught, I just figured out how to run the software and then, the machine along with it. So the biggest thing was to not have paralysis by analysis. You can't sit and worry about it. You got to press forward. And I broke a lot of stuff. I'll tell anybody that. I didn't machine through vices or into the table, but I broke a lot of tools. I was used to machining manually, both grinding, honing, and there's finesse. You can feel pressures. You're manipulating things on feel and sound. Same thing with manual equipment. We had a really old manual lathe, and we had a Bridgeport, and I taught myself how to make some simple little stuff with those things, but that was all by feel. You start pressing, you start feeding the cutter, and it feels like it's okay, I'll stay at that, or I better back up. So that all goes away when you get into CNC equipment, and you have to calculate a chip load, and you don't have any idea. So you burn them up a little bit, you break them off, and pretty soon you figure out, well, it'll run about in this area here.
Well, exactly. Well, Tony, it's interesting because, choosing the right instruments, so you chose the right instrument in the case of your world of racing, as it were. Picking that CNC machine changed that reality for you and allowed you to do open a new world, even where people are sending you faxes, for those people who still remember faxes, asking for parts to be done. So
yeah, we were really lucky that I was in business for 29 years until I was approached about selling the business, which has been done now. But we never did any advertising, which I wouldn't necessarily say is the right thing, but we were able to grow strictly through word of mouth, and we were lucky to develop some really good relationships with some engineers at places that they would work there for a while and end up moving on for whatever reason, and luckily they drug us along. The next thing I would know, we would have an inquiry from a quality department at some new company I hadn't heard of, and it was to try to get us on their approved vendor list, and then come to find out there was an engineer that we had helped out at a previous facility, and that allowed us to grow.
Well, we're now coming along to several podcasts, and it always boils down to, so far, the same thing. It's not the amount of time you spent in school. It's the desire to be successful and the desire to build things that really take you down this path. Was that true for you, Tony, I would think?
Yeah, I don't want to go too far out in the weeds here, but I will tell you, I went to college out of high school for a little while, and they asked me if there was anything I wanted to take, and I said, I got all this general ed stuff, that's all good, but I grew up in a machine facility. I probably ought to do some machine work just so I got some paperwork if I need to fall back on something here. So I went into a program, and I got asked to leave.
Really?
Out of this class. Yeah.
What happened?
Well, I don't want to get too. Basically,
how far out of the weeds do we want to go here?
Well, I could be a little bit out of the weeds. Basically, in high school, I was.
You're not on the witness protection program, are you?
No, nothing bad like that. It was just in high school. I was in FFA, and they had this project competition thing where they would send a group of. They were actually college professors primarily that were involved in ag schools, and they put this group together and they went around the state and. You did this project competition is what it's called. And it was a deal where you had some sort of project and you needed to present it to them, and they judged you on your presentation, but they also judged you on your knowledge of the subject. And my ag instructor came to me one day and said, hey, you're going to do this thing next week. I said, what? He said, yeah, you're going to do this. We're going to do this deal. So the only thing I could confidently speak about was engines.
Okay.
And, there's lots of engines in agriculture stuff too. So I did this project competition for actually a couple of years. I ended up winning it statewide a couple times.
Nice.
Which, that's here nor there. But the reason I say that is because when I went to this college, two of the guys that were involved in the college, I had won this little scholarship to go there, and two of those guys that were involved with the grade level counselor when I was in there were these two judges, and they wanted me to go through the ag stuff, and I was on the way to do the ag stuff and liked it. And when that machining question came up and I said, hey, I probably ought to take some machining, this one professor said, hey, don't put this guy in a beginning machining class. So I didn't know the difference. So that's fine, whatever. Mm-hmm. So they put me in this guy's advanced class. And the first day I was there, he says, how come you're here? You was transferred from another school. And I said, no, I don't know what you mean. He said, well, why are you in my advanced machining class? I said, I don't know. This is just where they put me. But to be honest with you, I grew up in a machine shop. I feel like I could probably do okay. He said, oh, so you know everything. That was day one.
Oh, geez.
So not long after that, he decided that my project was to rebuild a tree milling machine that got donated to the school. And I said, well, if you're going to grade me on it, that's fine. But you got to agree that you're going to send the table out and get it ground. You're going to send the coil out and have it ground and re-chromed. We're going to put ball screws in the X and the Y. We're going to rebuild the motor. Because otherwise, I got to be graded on something. I got to have good equipment.
Yeah, exactly.
He didn't know that I had actually done this at home because our Bridgeport,
sure,
I had to fix it.
Yeah.
So he didn't like that.
No, of course not.
No. So I said, all right, well, I didn't bring any tools. So he said, well, it's back there. Go take it apart. So I said, you got pallets or something I can put these parts on? So by the end of that lab, I had that thing stripped.
Nice.
So I took him over there and said, all right, there's the table. It needs to get ground. There's a knee. I want those ways need to be chromed and scraped. And we got to get ball screws. We need new bearings. The spindle needs to be ground. And he told me I was wasting his time.
Oh, my goodness.
So I had to come apart and told him he was wasting everybody's time. So anyway, I was asked to leave.
Yeah.
And he told me I'd never be a machinist. So I don't know if that lit a little extra spark under me.
Yeah.
May have. I don't know.
Sure.
I don't think it would have mattered much. But my point in going that far out in the weeds was I don't know if there's young kids out there listening to this stuff, but don't let somebody tell you can't.
Absolutely. No, that's a common thing, and I'm really glad you brought that out, Tony, because some people get discouraged, and you have to have the strength inside you to say, you know what, you did. We do generally have 10 quick questions we go through, as you know. We try to keep the show consistent, but I really love the way that we've started this and let young people understand, and not even necessarily young. I mean, Colonel Sanders started in his 60s, I think. If you have the desire, you can make anything successful, and choosing the right instruments are important. So if we maybe just touch a little bit on, you had the 32 control, SMP 32, was it?
They call it an MP32, I think.
MP32, right.
Yeah,
and it had the virtual Gibbs on it, right?
Yeah, it had the virtual Gibbs, kind of a 2.5 axis. It was a 2.5 axis.
Yeah. So is that what led you to selecting Gibbs Cam?
Yeah, that's exactly what it was. That was kind of my foundation for initial CNC code generation. And that guy that talked me into buying some more equipment, larger equipment, I said, well, if I'm going to do this with multiple machines, I can't stand in front of that machine. So originally the deal was he was supposed to purchase the software. I was trying to get him to have a little skin in the game.
Right.
And, yeah. So he agreed, but then backed out at the end. I had already bought it.
Okay.
So it ended up working out. I ended up buying an offline version. So we had the 32 MP and then the offline version as well. And well, actually, I take that back. When we sold, I sold that first machine with a 22-inch travel, and then purchased two new machines. I bought a 30-inch, a 3016, and then a 4020. So we went to two different machines, and that's when I went to the offline. So it was all kind of simultaneous there. And added 4-axis stuff at the same time. I put 4-axis drives on both machines. I think at that point, I only had one actual turntable. And to be honest with you, I can't remember if Gibbs had a 4-axis module at that point or not.
It did.
They did.
It did.
Okay.
Back in 90, this would have been 94, 95?
93, 94. Oh, yeah. That module purchase was probably 94, 95, somewhere in there.
Yeah. Gibbs always had a 4-axis positional configuration. And then in 95, well, somewhere between 93 and 95, the rotary module was released, so you could do some rotary on center.
Right.
Gibbs was always ahead of its curve, and it's interesting that Fidel is a California-built machine. Gibbs was a California-made piece of software, so you're pretty loyal to a California brand. That's also great.
Yeah, and to be honest, we ended up that way, and it wasn't as conscious as it sounds looking back in retrospect. But it was primarily because we had the dealership that we had, Magna, at the time.
Right.
And actually, once Magna came back to do the second training, it was probably 5-6 weeks, something like that. And the guy that came out saw some material sitting on the table, and he said, "How did you machine that? Because you don't have 3D surfacing on that machine or on that software." And so I showed him I'd found this deal where I could do it with a drive curve and
a base curve,
base curve and drive curve. And he said, "Hey, you want to be a beta tester for Fidel?"
Nice.
Sure. I don't know.
Yeah.
Whatever the hell that is, I'll do it.
Yeah.
So I did that for quite a while. I was beta testing their versions. And then, honestly, it just got so busy in business. And back then, the software, when we got a new release, it was a little buggy, at least at the beta level. I'm not sure now how that worked, but at that point, it was pretty buggy. So I ended up, I'd load a new version, start working on something, find a problem, end up having to back up to the previous version because they would get them solved pretty good. But I kind of didn't have time to keep doing that. The business itself was growing to the point where I had to bow out of that. But that was a really good experience. I got to meet the guys. Daniel Lacoste was my contact at Fidel, and so I stayed on the cutting edge with software for a little while, and then kind of faded away from that. But my point in all that is I ended up loyal to them primarily because of the dealership.
Nice. And then, of course, in selecting the software, and now you're getting more equipment. What was I'm going to say, probably the most important thing? Was it the software? Was it the support? What led you to stay with your course?
The primary thing was a familiarity. I had been using it for quite a while. I've been using this stuff since 92 or 93, whatever it was. And I grew with the product. So it was easy for me to stay on that path because each revision of the software was an incremental growth for me.
Right.
Versus somebody coming in now and, there's hundreds and hundreds and hundreds of features that didn't exist when it was basic. So that was part of it. The second thing was that we had good support for the software itself, and we were able to be able to purchase modules as I was purchasing equipment with more and more features. So we went from those two verticals. We bought a turning center, so we were able to buy the turning module. The turning center was just a 2-axis at that point. So we had a 2-axis turning center. We were doing the rotary ops in the mills.
Yeah.
And that was kind of the evolution for us. And then very shortly after that, we started getting into 4-axis horizontals. And then we started updating the lathes to twin spindle, live tooling Y-axis, and then all the way up to 5-axis equipment.
Yeah.
And it was a modular shift for us. We were able to buy modules as we went. And honestly, I stuck with it primarily because I didn't want to spend the time to find other things, and I had gotten lucky. We did have to trade dealers at one point. We had some post issues that it took us a while to get straightened out, and we were able to get them nailed down, and we got to the point where, and I think this is really, really important for anybody out there, you have to get your post processors set correctly.
Yeah.
And in my opinion, you should not be hand editing code. In fact, we didn't even save programs. So we would post a program, send it to a machine, and we did a lot of cut and run where we weren't a prototyping shop, but we did a lot of small runs as well as large runs.
Yeah.
But one of the strengths in the business was being able to cut and run, and we might do 5, 6, 7 setups in a day, and these are on 4-axis horizontals. And one of the things was we wouldn't save the program, send it out there, especially on the turning centers. For better example, you might have just got done with a job where some tools are in a different order. We didn't go back and move the tools around to match the last posted program. We'd walk in, change the tool numbers in the programming area, and fire that program back out with the new numbers, new tool numbers, or whatever it was. And that was it. That we ran that.
Perfect. And you're ISO compliant, so that's fantastic. That's the way they like it.
Yeah. And the other thing that we did very, very diligently was, as we were running a program out from the first time it was run, any of the tune-ups that we were doing maybe manually with manual overrides on the machine to take care of a chatter problem or take care of a chip problem or a coolant problem, myself and my guys addressed that right at the machine. We would post it, send it, and then come out with a laptop that sat right next to the machine. And my rule was the source code has to be right.
Yeah.
So and in the end, it became as minute as it sounds, it becomes a really, really important aspect later down the road.
Exactly.
To not rely on tribal knowledge. And the last guy that ran it, he didn't tell you that he kicked the feeds up and the speeds down, or vice versa.
Exactly.
So.
One of the things that, sadly, I guess sadly, you sold the business, and I think Tool Manager IQ would have been great for you to be able to keep track of those tools. And part of our first question, I know Steffi's waiting to click that button and show us that question.
Oh, all right. Sorry.
No, that's okay. We digress, but this is all really important. So, in selecting the most critical factors to consider when you're really selecting tools for CNC machining, and the reality is has a lot to do with the part, it has a lot to do with the material, but I'll let you address that.
Yeah, I would say that the primary thing is the part or the family of parts. Obviously, you need to figure out whether it's a turning part that has a small amount of milling, or whether it's a milling part that potentially has a small amount of turning. We did a lot of milling stuff in lathes that you wouldn't normally do, but we did that because we could bar feed it. So I think one of the biggest things, especially nowadays, is that you need to really consider purchasing equipment that will take care of the family of parts as close to completely automated as possible. Whether that means pallet changers with multiple pallet instances on a horizontal, enough tool availability in the horizontal, in the turning centers, at least bar loaders and parts catchers, if not robotic slug loaders. I think it's one of the downsides is as you're building a business, it's really hard to justify the costs initially. Mm-hmm. And then as you grow, you realize, boy, I really need some more automation. I need this process to be solidified and have less human interaction. And it's not because human interaction is bad. It's just that it's required. And when it's required over and over again, you're going to have a process failure.
Yeah, somewhere down the road. And,
maybe somebody just gets sick and can't come in. That's as simple as a simple process failures you can have, and it will still change the outcome of your business.
Well, absolutely. It kind of leads into the second question. I'm going to kind of tweak it a little bit. So in the material selection, how does it obviously impact the choice of CNC tools? And, the word CNC tools is a bit obscure too. Tools are tools. Where I'm going with this, Tony, and you kind of touched on it a little bit, selecting the right holders and the right tools also have a lot to do with the machine tool you're using, right? And its rigidity and its ability to maintain tolerances. When would you decide, let's say, to buy a more expensive tool as opposed to something that you can just get off the shelf?
Let me just ask a quick question for clarification. Are you talking about the actual cutting tool, or are you talking about the holder and the holding system?
I want to say it's a combination of those, because really on a CNC, I mean, you can pick up a 1/2-inch end mill, but how that's held and what machine that's on and how many parts you're going to build all have to do with what you're going to buy.
Yeah. So the one thing that is, I don't want to say difficult, but one thing that's not necessarily appreciated early on in this is that concentricity of the tool, rigidity of the tool, and rigidity of the machine center all play into how controlled your process is going to be. Yep. It also opens the door or flat closes the door for aggressive speed and feed improvements. You can take two tool assemblies that look the same, but don't have the concentricity of the rigidity. Yep. And you can either have a failure in the part or a consistent running process. So machine tools themselves, rigidity is always a huge issue. Yeah. But you still, and I think there's a really good balance nowadays with machine tool builders where you're able to buy equipment nowadays that has sufficient rigidity and the ability to accelerate and decelerate, make really good moves. And that's evolving, daily. And
sure.
So until you have really good cutting tools and cutting tool holders, you can kind of cripple yourself on that end of it, meaning you could take a really good machining center, may not have as good a performance as you expected if you don't have your cutting tools and the cutting tool holding system nailed down really well. It affects everything, especially tool life. And
right.
Yeah.
Well, kind of, again, all of these are leading to each other in selecting the right instruments. And question 3, we talk about the difference between selecting the right materials, whether it's a carbide, whether it's high-speed steel, whether it's diamond or ceramic, whatever it might happen to be. When do you decide to buy that type of tool? How do you decide to buy, a more expensive tool, a less expensive tool? Is it really the number of parts you're going to build? Is it the speed that you want to build them at? What kind of thoughts go through your mind at that point?
Well, once you have a portfolio and you have a business that's moving along, in the beginning stages, I bought really cheap high-speed steel end mills because they didn't have a really good life expectancy at my hand.
No.
So, that's just the reality of it. And then as you develop processes internally, you realize that, carbide tools will basically the premise of all the tooling is heat management. That's really what it comes down to. Every cutting process, in my view, it can be boiled down to heat management. And carbide tools have better heat resistance, allows you to run a higher RPM. There's another side benefit. Carbide tools are generally stiffer. High-speed steel will get you through some stuff. You're going to run at slower speeds and slower speeds, but there's a cost difference, right?
Yeah.
So I would say that once you have some processes under your belt and really understand cutting, you're going to end up with a basic premise of what a 1/2-inch carbide end mill runs like in your machine. What kind of depth of cut, what kind of feeds and speeds are the sweet spot for the harmonics of that machine and that assembly. At that point, I would say don't go back. Carbide is, I think, generally the most prevalent cutting material in modern CNC equipment.
Yeah.
High-speed steel,
yeah,
it does work.
Oh yeah, yeah.
But you're semi-handicapped. Now there are some very, very slight applications where you may want to stick with that. And for general purpose stuff, you're never going to get away from it. But we, through the years, basically went to 100% carbide everything, whether it was drills. Well, I take that back. Taps, not necessarily. We did use some carbide taps, but primarily, the powdered metal stuff, really, really advanced. But other than that type of tool, we just ran carbide. And one of the advantages was coolant through on almost all of those being available. And then the diamond stuff is all about heat management. We did lots of diamond inserts for hard turning. So we were able to eliminate lots and lots of post heat treat grinding operations with diamond inserts. We got into diamond coatings and DLC coatings, trying to increase tool life. And in some applications, we saw increases. In other applications, we saw a little bit of an increase, but it didn't offset the cost difference. So there's times where, when you get to a point where, especially in milling, it's in all cutting, but we were able to kind of figure out in milling, we would figure out what the tool life of an insert was, and then it's a pretty linear calculation. Once you get the rigidity, you get the system in place, we can make more parts in a day, but we incrementally decrease tool life. So then it's a math problem, right? You figure out what the math is. How many inserts can I buy?
Yep.
Keep this project running at this rate and still make money.
Yep.
And sometimes you back off and say, hey, we're going to lose a run of parts a day because the part value doesn't outweigh the extra insert cost. We had other jobs. We'll put as many inserts in there as we have to, because we need to make these parts as absolutely fast as we can make them. And it's semi-linear at that point.
Right.
If you have the other factors out of handled, you can't do that math linearly if you don't have adequate rigidity in the fixturing, good tool paths, good rigidity in the machines, good coolant, all those things. Well, in steels, we probably won't running coolant. But my point is, once you got all of the other factors out, you could kind of pencil it out and say, we're gonna increase the feeds and speeds by 35%, and we're gonna make 4 or 5 more loads today, and increase our consumables cost, but it's offset by the production. Other times you're gonna back up and say, nope, not worth it.
Exactly. And what made you choose, whether it was Sandvik or Kennametal or Iscar, what
the
brand did you pick and why?
I'll be honest with you. We used a lot of inserts. We cut a lot of steels, lots of stainlesses. Even though we're in California, California's kind of known for aluminum, and we cut piles of aluminum too.
Yeah.
But we got into some customer bases where it was a lot of chromoly, lots of 4000 series, and we tested lots and lots of stuff. We had really good support from our tool suppliers, and we had some field reps that would come out and they would say, "Hey, are you willing to test it?" Well,
Sure.
hell yeah, we'll test it. Throw it in there. As long as you're going to guarantee it when I snap the bottom off of it, we'll guarantee it. So we'd run it till she blew and back up, say, okay, this is what we got. So that drove some change throughout the years where all of a sudden we'd have different applications. And we didn't have one standard brand that we used all the time. It was, we'd test 4 or 5 different manufacturers for a project, and we were usually pretty aggressive. So we take them and plug and play. All right, you're going to put it in the ramp. Here's what we're running now. And they'd say, yeah, we'll do a guaranteed test. I said, here we go. And if all of a sudden we got better tool life, hey, we might shift to that.
Yeah.
So the other thing, selfishly, I wasn't going to have one supplier. I need all these guys. They all need to be available to me. Same thing with tool dealers. Same thing with machine tool dealers. One of them isn't good. You got to have all of them, or you only got one option. So we kind of spread it out. And we had good success with each of them. I can't say that any of them. I think all these companies now make really good products. And now it's just finding that extra 10%, if that, you know what I mean, just to throw a number on it.
Well, and I would say potentially inventory too, right?
Availability is huge. That's number one.
Do you have the inserts? Can I get it tomorrow? Can I get it this afternoon?
Well, that was one of our stipulations, because we're so remote. When we got to that level, we would say, okay, we tested the tool, we like it, it gave us a little better performance or a little better tool life, whatever it was. We have to make sure that our local supplier is willing to stock it for us. And we had that. We also bought a bunch of them and kept them in the inventory ourselves. Just make sure you have them. I don't care what it costs. It's in a machine city.
Well, yeah, you don't want to be down production because you don't have the inserts. And
right.
What did you do at the time to manage that inventory? How did you know where the inserts were and the tools were? How did you have control of that?
Well, we did it. I put in a really, really extensive, basically toolboxes. They were similar to List. I think we got them from Rousseau, and I think they were about 5 feet high, 48 inches wide, with hundreds of dividers in them.
Okay.
And we literally, it was a manual system at that point, but we had very designated areas for each of the cutter bodies, each of the indexable inserts that went with them. And it was literally hillbilly management. You open the drawer and you got down to the last box of inserts. Somebody better order some more inserts. That's really all we did. I think there's a lot better systems out there, but the big thing was having the organization to make sure that it was readily visible to anybody that, hey, we're getting low on this stuff. Right. And we did the same thing with every machining center had toolboxes with all of the tools that they required for that machine. And it was based on the same principle. It was just that, hey, we needed, if there's a hole somewhere in this box, we're missing something.
Yeah. Yeah, that kind of goes back to lean, right? If you know where everything is, then you could take a glance and say, hey, wait a second, that vernier is not where it is, or that inserts aren't, those DMG inserts aren't in there.
Right.
So, yeah, that makes total sense. We're talking about the latest innovations in CNC tooling, and, there's all kinds of things. What were the last machines? Were they Okumas that you had? Did you ever use some of those, what do they call those? The flip tooling, how they kind of rotate from one side to the other. One side will be a 35-degree diamond. The other side will be an 80-degree diamond. I
think so I did not, prior to me selling the company, actually that was probably going to be the next machine that I purchased. So I classify those as B-axis lathes. So those turning centers have a full-blown milling system with usually a tool magazine in the back of them. And they use like a Capto system or an HSK for the tool holder. And that tool holder can either be a rotating milling cutter or it can be an indexed turning style holder. Is that what you're talking about?
Yeah,
where you can
exactly.
Yeah,
exactly.
So I did not. I had multiple Akuma turning centers. We had Makino horizontal machine centers, Akuma horizontal machine centers, Micron 5-axes, but that was the next machine to purchase, and then we ended up selling.
Yeah. Well, obviously they liked what you were doing.
Yeah,
understandable. So, and I think you kind of covered question 5, how do you balance cost and quality in purchasing not just tools, but also equipment? Where does that, how did you decide?
A lot of that, I just studied machines, talked to lots of different guys and talked to dealerships, and it came down usually, you got to have good hardware. Right, you got to make sure that you're buying good hardware. But I don't care how good hardware is. There are going to be issues when they first install it, and there are going to be issues with it in operation, whether it's self-induced or just the nature of it. And having people available and having good support is invaluable. It doesn't matter how fancy a machine is; it's not worth anything if it's not making chips. You can do a lot of things in these businesses, but you are not generating income if the chips aren't hitting the conveyors. Bottom line.
Oh, agreed. And again, on topic, but slightly adjacent. It's not just the tool; it's the tool path.
Oh, without a doubt.
Right. So the methods behind the programming. And I you're a great programmer, I know from experience, but using things like volume mill and voluturn, how did that change the direction of selecting the tools?
I think the biggest thing was it let us step on the throttle a little more. Basically, the premise of having a constant chip engagement is huge. Frankly, I had to do that manually, and I did that for years. I would create all kinds of different paths that were related to the base part, but I wasn't actually using the base part for a similar thing. And then when options like volume mill came out, it was a game changer. I personally, I think you have to do a little balancing because you have to take into consideration the actual acceleration and decelerations of machine tools.
Yeah.
So, lots of the tool manufacturers will tell you, hey, look, you want 1.5 inch axial and you want about a 40 thousandths radial and you're going to go 800 inches a minute.
Yeah.
And on the screen, that's going to take about 10 minutes out of your tool path. Everybody wins.
Hey,
but when you get out at a machine and you start watching a machine having to accelerate and decelerate for every positional change, you don't necessarily gain it. Where you do gain it is using a hybrid version of that, where you let the software give you a constant chip thickness.
Yeah.
But you find that sweet spot where you're taking a little more radial cut or axial cut, a little less feed rate, but your cubic inches are actually going to go up because the machine will actually attain the feed rate that you have on the screen. So it's a game changer without a doubt. It's huge. You just, in my opinion, you have to tweak it a little bit to get it to really be effective, and then it's unbelievable. One of the nicest things about that process was once we implemented that, once it became available, we jumped on the bandwagon right away, kind of found our way of using it, and it was really, really nice to be able to start a cutter into a piece of material, listen to it for the first 5 or 6 seconds, and know that those are the cutting conditions. It's really not going to change. It's not all of a sudden going to bury itself into a corner and snap off. So
no, exactly.
Yeah, huge.
The chip load was always respected. It's one of the things I liked when we first started using that type of process. And in the early days on the Matsura FX series, all the toolpath had actually to be incremental
Right.
to be able to achieve that type of toolpath. But Gibbs took that a whole other direction, allowing you to work in absolute and working on the modern machine tools. When did you decide, and I know this is not one of the questions, but did you decide to run some carbide dry and sometimes with coolant? When would you pick that?
So again, I kind of boil all cutting down to heat management.
Yeah.
And if you're running in the steels, in my opinion, if you're running the tool fast enough meaning fast enough
Sure.
heat, right? That's generating your heat.
Yep.
And then you're matching your feed rate to the rigidity of the whole process. That's kind of how it works. I mean, that's boiled down, but that's kind of the premise of it, right?
Sure.
So what happens in steels especially, you can get away with this in some stainlesses. Sometimes you still have to run coolant. You have to run a slower surface. But the bottom line is that you want to generate enough heat in the cut to plasticize the material a little bit right at the cutting zone, have it freely leave the parent material, and then keep the heat in the chip, not transfer as much into the cutter insert and body. But in that sweet spot, if you are trying to run coolant, you thermally shock a milling cutter because it is superheating, for lack of a better term. That's not truly accurate, but just for thought process.
Of course.
You're superheating that as it's passing through the cut. And as soon as that flute clears the parent material and the chip leaves it, now you thermally shock it. And what we found, and I think a lot of the carbide manufacturers will agree with you, is that you will actually shorten your tool life immensely. Because once you get the surface footage up to the point where you're generating enough heat to really cut the way you want to be, you're going to thermally shock those and you'll start breaking the cutting edge down. Not because you're doing anything wrong with the feed or the speed, you're just thermally shocking it. Now, some of the stainlesses, you can't do that. It wants to weld itself.
Sure, yeah. Well, I agree with you. And it becomes about, then chip evacuation. And at that point, if you have good chip evacuation with the general cut, some people decide to use air blast as opposed to a coolant, right?
Yeah, and we did the same thing. And to be honest, we did use it for chip evacuation in cavities and whatnot. But in the steel applications where we were really hauling ass, we still ran air, and that was just for a little more heat management. It would help some heat dissipate through the cutter body without thermally shocking it.
So, okay, let's get a little deeper into what type of tool geometry. What made you pick up a different type of tool geometry than one or the other?
Well, at first it was recommendation by tool manufacturers, right?
Sure.
We would end up with a new product with a new material and some new configuration, and you kind of have an idea how you're going to go about it. And that's really, we'd start with what we had, right? Hey, we got these or those, and we'd start going. And then we would start bringing different manufacturers in. And there were times that we ran conventional indexable insert mills. Other times we would apply, I think it's probably been 15 years, don't quote me on that, but there was a push to go to these high feed cutters, and we utilized them, and they had their application, and they worked great. It's kind of just adapted as we've gone, and it's been mainly material specific. Sometimes the parts themselves and a little bit of something, you may not be able to push on something as hard. You just got a big chunk of material you're holding on to. Well, you can plow it off there with whatever you got. Sometimes you got something you have to finesse a little bit. You end up having to run a little higher or a little sharper edge prep on the inserts, and that frees up the cutting force. Might kill the tool a little bit.
Exactly. Remember, when we were selecting tools for roughing, depending on, is it 4140? Is it Inconel? Is it titanium? Maybe you would decide to use a 6 flute Strassman cutter, or you may decide to use an insert cutter. And I guess what I'm hearing you say is you just used what you thought was best for the application until you thought something else was better.
That was kind of the premise. I'm 100% self-taught, so I didn't have a big library to go pull from to start with.
Right.
You generate that over 29 years, but in the process, you just run with what you brung and then see if you can make it better. And that's probably another thing that I do push as well. That you can't let your processes be stagnant. Even in jobs that you've run for a long time, I see or hear about people that, hey, that thing's been running like that forever. Well, that's great. If the efficiency's up high enough, well, don't mess with it if it's right. But don't rest on your laurels either. You got to always try to figure out some way to be more efficient. And honestly, in a matter of years, tool technology changes. The cutting tool technology changes drastically. So there are times that, you think, oh, I should probably leave that alone. It's been running good. Well, you might be leaving some money on the table. So you need to evaluate that.
Well, exactly. And, obviously picking the right tool makes a difference. And if you're only making one part, then you can probably use something existing in the library. But if you've now got a whole batch of components you've got to build, you're now probably doing a little more research into what the right inserts or what the right tools are going to be, and potentially the right holder, or at that point, the right CNC machine tool, right? If you've got a large enough batch, right?
Yeah, absolutely. And there's, even if you're doing one, if you're testing things continuously, all of a sudden you're going to find something that works really good just for one part because you've done it 3 or 4 or 5 times or 10 times, and it evolves. That's a good thing about this business. You got to stay with it, but it evolves continuously.
Exactly. So if we look at, we talked a little bit about the holding systems. What type of, do you go with a shrink type, or do you go with a side lock? Do you go with a collet? What made you decide on that type of holder solution? That's question number 8 for Stephanie, I believe.
We started out with, I think, like most people, you're building a business and you don't have a lot of extra money and you don't know where you're going to put money when you do have it. So you start out with side lock holders and things like that. So our first system, I guess if you want to call it, was in our horizontals. We had a standard library of tools, and we had roughers for almost all of our sizes that were common to us, and then a finisher. And we started out by using side lock roughing tool holders, and most of our finishers were in ER style collets.
Okay.
That was the first, I'll say, evolution of a real life system. And then from there, it graduated to some hydraulic holders. And
that's the shunk style kind of deal?
Yeah, we had quite a bit of those. We had shunks. Can't even remember the other manufacturers. We had quite a few different ones. And the shrink stuff was coming out, but frankly, most of the shrink stuff when it first came out was a pretty long, long hangover ratio. The gauge lengths were really long.
Yeah.
And so my thought was like, well, great, you can grip a tool better, and theoretically it's going to be more consistent, but that's the wrong direction, being longer.
Yeah,
you want as short of overhang as you can get.
Yeah.
So I was kind of skeptical of that whole thing for a long time, and we shied away from it.
Okay.
Honestly, tool holder manufacturers, not because of me, but just in general, started developing tool holders that had shorter overhangs. And all of a sudden I thought, okay, you know what? It seems like it's maturing to the point we need to get on this bandwagon. So sure enough, we did. We went full tilt and bought the shrink systems.
Yep.
And started shrinking most everything. And if there was any reason that we couldn't use it, we wouldn't. But other than that, we pretty much shrunk them. Rigidity, concentricity, all those things just went up, and tool lives almost immediately improved.
Exactly, and I think that's the key. What system did you use then at that time? What manufacturer did you end up getting? You remember?
Yeah, we went with Technics. We had been using quite a few Technics tool holders.
Okay.
We had a good rep. Ended up being a personal friend of mine through the years.
Nice.
And had great support. I could call this guy. I'm like, hey, I need such and such. Hey, if I don't have it in my inventory, I'll get it to you tomorrow, kind of thing. And so we went with Technics shrink system.
Nice. And that impetus was because they had a shorter stem.
Yeah, and that was just my bullheadedness, to be honest with you. They might have been just fine before we got into it, but it didn't seem like the math was right on that deal for a while when they were long gauge lengths, and then you get into 5-axis stuff, and sometimes and some horizontal stuff where you do need that long gauge length. And a long gauge length with a shrink is better than a long gauge length with something else. Don't get me wrong. But I just didn't see at first. I just didn't see the need to jump to that and give up some rigidity because of the gauge length. So when it got to the point where I felt like it was the best of both worlds, you got short overhangs and you got really good concentricity and a good grip. Let's do it.
Well, Tony, our last question, when we already covered it really, about the best practices of storing tools and the reality of maximizing their lifespan and effectiveness. Do you, and maybe just to refine that a little bit, did you end up ever using tool life management on the machines or using it through Gibbs? How did you manage that?
We use tool life extensively.
And did you do it by time, by tool change, by number of inches of removal? How did you manage that?
It was machine based, but our primary go-to, and this was, we got really involved in it when we first bought our first Makino. They had a great system for it, and it was based, you had different options. They could do a tool study where you would actually hit a tool study button and run the tool. It would monitor the loads along the tool path for the entire use of the tool. And then you could set parameters, say, all right, I'm going to allow you to increase load by 30%. I'm going to allow you to decrease load by 5%, right? If the load drops, all of a sudden the tool's broke.
Right, of course.
As the tool wears out, hey, I'll let you go 20, 30, whatever that factor was. And that worked well. For simplicity and time's sake, we just went to a time of use. And we would have, my goal was about an hour in the steels. When we were in steels, give or take, I wanted the inserts to last about an hour. If I wasn't getting that, well, either a different style insert or I got to tune up this tool path. If I was getting more of it, I got to step on the throttle. So that was kind of our deal, and we were able to put, redundant tools in the machines. We had large tool mags on all our horizontals, and so we would have, 2, 3, 4 backup tools, and let her rip. The people were able to manage the process instead of having to just manage the actual part, if that makes any sense. They were able to get pallets loaded and running, and they'd start getting alarms for tools, and they may be on the third tool in that family of tools. They can go change some inserts out, revitalize them in the tool or the machine control. They were really stopped.
Yeah, and I guess if you're using tool life management, you were probably having some type of system to manage the tool length and tool diameter. Did you have probing of some type, or what did you use for tool breakage?
For tool breakage, we had some probes. I personally didn't like using them as often, frankly, because it added cycle time. There were applications where we just needed to, and that's fine. That's the way it is. But as a general practice, I did not hey, I'm going to go check every tool after its use to see if it's broke. We got better at judging tool life and putting redundant tools in so that it didn't stop. It was just that, if we drilled, for an hour, we wanted to replace that drill, or at least look at it. Sometimes you look at it and say, hey, we got an hour on this. We got an extra hour on it. This needs to be a 2-hour tool life. So we adjusted that sort of thing. My thing was early on, we bought a Speroni tool setter, and I don't have any plug for Speroni. They're good stuff as well.
Sure.
And my point is that offline tool setting was a game changer. The other thing was that in vertical, when we were just a vertical shop, we used negative tool lengths, and it worked. It was fine, but the tools were set for that job, right? Once we got into a presetter, we got into the positive tool length with a negative Z fixture offset, and now tools that were in the magazine were truly available for whatever part we had. Because they were relative to each other and relative to the gauge line, and then you adjusted your Z value to the gauge line, and you didn't have to reset them. And that expanded us in the vertical world, but especially in the horizontals. They're much more common in horizontals. I mean, I think most people in the horizontal machining world use positive tool offsets, and those tools are not set to a specific part. In verticals, because some tool changing or some tool setup cycles are inherent in the controls, we fell there by default. I didn't know the difference. That's how I did it. So we, not long after this started, we got into tool setters, and I think they're invaluable. I think one of the things that's really, really important is that you have to systemize your shop. You have to create systems and processes, because you have to be able to train other people. One of the biggest downfalls for anyone who starts their own business is that we become an employee of the business and too busy working day to day in the business. It's not scalable, and you're not as available to build your business because you're not working on the business, you're working for the business. And I bring that up because you cannot have efficient delegation until you have really good systems in place. And sometimes that means more equipment than you want. Exactly. For example, with Speroni, coordinate measure machines, ERP systems, CAM systems that have good post processors. All of those things are required in a business like this to be able to have delegation where people can be trained and you have a system. And as hard ass as you have to be on the system, you got to be able to adjust the system if there's a failure. And employees are really good at showing you things that you were short-sighted on. Take it to heart. Adjust the system, but keep the system in place for everything. Because otherwise, and I did this for a long time, you got a line of people standing at your office door trying to ask you questions, which that's always going to happen at some level. But it's terrible until you get a good system in place. And it is relieved once you do have a good system in place and you're able to train people. You have procedures. Run with it. You have a place for everything. Make sure that stuff's in its place.
Well, Tony, that's incredible. I mean, the wealth of knowledge that you've got there and the recommendations to people in a shop are I'm really glad I had you on, and we could actually be talking here for hours. On this topic, but we've covered the questions, and you really highlighted the importance of the right instruments, whether that's the machine tool, whether that's the software, whether that's the type of tool, and how those things are managed to have a successful business. And I appreciate that.
No, thanks. I never dreamed anybody would want to hear about my story, but appreciate the opportunity, I guess.
Always thought you had a lot to share in the industry, and we've always appreciated it, Tony, and I thank you for that. It's nice to be able to share that, because what do they say? They say for every 5 tradesmen who retire, there's only 3 that fill that spot. And
I've said for a long time, Al, people don't realize that I don't care how many doctors and lawyers you make out of college, and college is a good choice. I'm not saying it's a bad choice, but the bottom line is I don't care how many doctors, lawyers, psychiatrists that you create. They're not going to fix their own cars. They're not going to build their own houses. They're not going to fix their own plumbing. They're not going to fix their air conditioners. They don't know how to make anything. And that's fine. But that means that there's a vacuum for all of those. So, especially in the United States, I don't know about anywhere else. We really lost teaching the value of vocational work. Yeah. We told people for decades, if you don't go to college, you're not going to amount to anything. Well, number one, it's not true. And number two, we're in trouble. We got to get this turned around and make the effort to have some vocational education. People can make very good livings, whether they're a tradesman that works for somebody else or whether they decide, you know what, I'm going to do this on my own.
Yeah. Oh, for sure.
You're willing to work for it, you can do it.
Well, Tony, I agree with you 100%. We've always been behind that, and we always do a lot of training. For new people, we're always ready to take in co-op students from high school, and we like to take them right out of high school and put them in a trade position so they can learn and progress in their life, as opposed to wasting a lot of time learning about things that they'll never use.
Yeah, true. Well, and the other thing is that they're 4 years behind in their retirement and usually a big old pile of money in debt. So
exactly. And
if you figure out the math on making it work, that's great. But a guy goes to work and starts putting some money away and maybe decides to do his own gig. You'll be all right.
Well, Tony, thank you for joining us. Really appreciate this, and look forward to maybe having you on again another time. But this was a really good conversation. There's so much more to talk about. But have a great evening. We'll bring Steffi on, and thanks again for joining us.
Absolutely. Thanks for the opportunity.
Thank you, Tony.
We'll see you.
Cheers. Hey, Steph. Oh, I think your audio is muted for some odd and unusual reason.
Happening all the time.
Is your dog barking back there somewhere?
Yeah, I got to make sure she's not interrupting the noise.
Well, that was a great show, Steffi. It was wonderful to have Tony on. And we had quite a few great comments, and it's nice to see people engaged with us on the different streams. Absolutely. Anything you'd like to talk about for next week? Who's coming on?
Next week we have, it's called Digital Craftsmanship, Navigating the CAD/CAM Landscape, and we have Bart.
Bart who?
Bart Ellers? Is that the right pronunciation? I always get nervous with pronouncing names.
Oh, you're right. You're right. And it'll be great to talk to him about that. What was the title again?
Digital Craftsmanship, Navigating the CAD/CAM Landscape. I have some seasonal allergies, so I'm really nasally. That's why.
You're not smoking in the back, I guess.
No.
No. Very good. Well, Steph, thank you very much. Tony, it was really, we could have been on for another couple hours easy. It was really engaging. So I guess I'll let you sign us off, and thanks again for being my co-host. Thank you. I'll play the intro and then we'll... The outro? Oh, yes, thank you. The seasonal allergies are getting to me. Bye, Steffi. Ciao.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast. Hey, little Steph. Oh, hang on.
Oh, did Tony leave us?